Hello, people of geometry, and welcome to 3.5. I wanted to just check in with you and see how 3.4 went. That 3.4, doing proofs, is one of the most difficult things that mathematicians do. And what you got was merely a glimpse into kind of what a proof could look like and should look like. And when you do proofs, you really have to consider what information are you starting with? What information are you working from? And then what do I know, or what can I add to it that can help me get to my conclusion, or to the conclusion that they're asking me for? Okay, so proofs, they don't necessarily go away, but it's just kind of a different way of thinking than maybe you're used to, and it's good. It's good to be, it's good to think about things different ways. So now, on to 3.5. In 3.5, you're talking about isosceles and equilateral triangles. So what are isosceles and equilateral triangles? Isosceles simply means that you have two sides congruent. And remember, equilateral means all sides are congruent. And there are a couple of things that come about when you're talking about isosceles and equilateral triangles. So let's talk about these. So this is called the isosceles triangle theorem, and it's not too brain-breaking, but it is a nice idea. So if you have got two sides of a triangle are congruent, which basically just means you have an isosceles triangle, okay, that's all that says. You have an isosceles triangle. Then the angles opposite the congruent sides are congruent. Okay, so said more mathematically, in mathematical language. So if I have AC congruent to BC, okay, which is AC congruent to BC, then angle 1 is going to be congruent to angle 2. So in an isosceles triangle, whichever two sides are congruent, their opposite angles are congruent. Okay, so looking at it a different way, if I had it set up this way, where these two were congruent, then I would say that these two angles would be congruent to each other. And that's a big piece. Okay, that's a big piece. And one other detail that I want you to remember, because it will come up, is remember that my total angles has to equal 180 degrees. Okay, so this is a fact that's going to help us in using this. Okay, so just if I have an isosceles triangle, the opposite angles, these are sometimes called base angles. Are going to be congruent. Okay. So if it works one way, it works the other way as well. So if I show, hey, angle 1 is congruent to angle 2, which they have marked here, then if that is the case, then I can say those opposite sides are going to be congruent. So I can say DE is going to be congruent to FE. DE is going to be congruent to FE. So it works forwards and back. Okay, and the big picture is that if I have an isosceles triangle, the base angles are congruent, and if the base angles are congruent, then it makes it an isosceles triangle. Okay? Okay. So now if I can kind of consider this, look here. So I've got a triangle, and these two marks tell me that those two are equal. Okay, so I've got angle P is congruent to angle M. Okay, the markings indicate that. And they're not asking me to find what those angles are, but the fact that this is 120 makes my life easier. I could figure out the measure of those angles without too much trouble. Okay, I would use this plus the fact that all angles have to add up to 180, and then I could figure out what those two angles are. But that's not what they're asking. That's not what they're asking. They're asking for how long is PN? Well, since these two are equal, these two angles are equal, the opposite sides are equal. So if this is 11, this is also going to be 11. Okay, so that's also going to be 11 centimeters. and we're done. That's all they're asking for there. Yeah, not too tough. So now, if we're looking for a value of z, so they give me all three sides, in a manner of speaking. Okay, they don't give me a flat out number for this, but that's fine. Okay, so then they tell me, you know what, these two angles are equal. Okay, if those two angles are equal, then the opposite sides are equal. Okay, so 2z minus 15 is going to equal 9. Okay, it's going to equal 9. Okay, based on the fact, okay, these two are my base angles, that tells me I'm using these two sides. Okay, the 7, you know, it's nice to know that that's 7, but that doesn't help me to solve the problem. Okay, so just kind of be aware of which sides you're using, because it could be very easy to say, hey, wait, does it equal 7? No, that's going to be wrong. You're using the wrong side. So then it becomes an algebra problem, which you should be getting better at. So divide by 2, z is going to equal 12. And that's what they're asking for. That's what they're asking for. Figure out what z is. Okay, so let's look at a proof. Let's look at a proof. I told you that they're not going to be, that it's not going to be easy. I told you that they're not going to be, their proofs aren't going to go away. So let's see what happens here. Okay, so they say LM is congruent to LP. That's a given statement. LM, so let's mark that. LM is congruent to LP. Okay? And you're trying to prove that M is going to be congruent to P. So you're basically proving the isosceles theorem here. Okay? So here's what we're going to do. Now, hopefully you saw that, you know, you have LN, and LN is part of both triangles. So hopefully you noticed, hey, that's part of both triangles. So I can use that reflexive property and say, yep, those two are equal to each other. Those two are equal to each other. Okay, so now where do we go from here? Okay, so now where do we go from here? And this is going to be a little bit of a leap of faith, so you're going to have to listen to this part. If I've got an isosceles triangle, which is what this given statement told me, if I've got an isosceles triangle and I drop a line from my point straight down, which is what this pink dotted line is. Okay, this is called an altitude. Okay, it's called an altitude, and it's straight down, or in this case, you know, straight across. It does two things. One, it's a 90-degree angle, and two, and this is only true in isosceles triangles, it cuts this in half. It bisects the far side. Okay, it bisects the far side. So what I can say is that these two sides are congruent. Okay, so I can say, you know what, MN is congruent to PN. Okay, and the reason for that is that in a isosceles triangle, the altitude bisects. Okay, so I mean this is kind of a longer explanation. I could just, you know, if I wanted to shorten up, I could say definition of bisector. Okay, that's going to be kind of what we're looking at. Okay, so now let's look at what I got. Let's look at what I've done by doing this. So those two are equal. So now I can say, go back to my purple here. So now that's when I can say triangle LNM is congruent to triangle LNP by side, side, side. Okay, because I've got three sets of sides. So then my final piece would be CPCTC. So this step, this blue step, this step 3 is kind of my big part here. It's kind of my big part. Now I wouldn't expect you to remember out of the blue that the altitude bisects in an isosceles triangle, but that's kind of why it happens. That's where it comes from. Okay? Okay. So in an equilateral triangle, as we've said before, all 3 sides are equal. And as a direct result of that, all 3 angles are equal. Okay? All 3 angles are equal. Well, let's think about this. If my total has got to be 180 degrees, and I've got 3 congruent triangles, all I'm going to do is divide by 3. So that's going to be 60 degrees. Okay, 180 divided by 3 is 60 degrees. So in an equilateral triangle, big piece, in an equilateral triangle, my angles are always going to be 60. Okay, and this is, triangle is equilateral if and only if it's equiangular. That means if it's equilateral, it's equiangular. If it's equiangular, it's equilateral. It goes back and forth. It's true both ways. Okay? Equilaterals are useful because that tells me that everything, because I'm going to know what all my angles are, which is going to help me tremendously. So now let's look at here. Let's look at here. So they tell me that this is 60 degrees. They tell me that this is 5 and this is 5. Well, if this is 5 and this is 5, that makes that isosceles. That makes that isosceles. Okay, so this is 60. These 2 are 5. That means these 2 angles have to be the same. Those 2 angles have to be the same. So if I know my sum's got to be 180, I subtract this 60. Okay, that's this 60 here. I'm left with 120. And these 2 got to be equal. So I'm going to divide that by 2, and I get 60 there. So just by calculating, I get that this is 60 and this is 60. So this is actually, while it appears to be an isosceles, it's actually an equilateral, which means that this last side is going to be 5 centimeters. Okay, moving on. Okay, let's see what we got here. Okay, true. Okay, so this, we have a great big mess going on here. Okay, so they say this is 4x minus 8. This is 4x minus 8. Okay, so but they also tell me that these 2 sides are congruent. So if these 2 sides, this DF and this FE are congruent, that means that the angles are congruent. Like this angle and this angle are going to be congruent. Well, if one's 4x minus 8, then the other one's also going to be 4x minus 8. But they're all 3 4x minus 8. So they're all 3 congruent. Well, the only way that's possible, the only way for all 3 to be congruent is if it is an equilateral triangle. Okay? It's going to be an equilateral triangle, which means every single one is going to be 60 degrees. So if I'm trying to figure out x, I know that each one of those has got to be 60 degrees. So then a little bit of algebra later. X is going to be 17. So to figure out what y is, well these 2, this is isosceles, so these 2 are definitely congruent to each other. So doing some algebra, y should equal, I get 4 there. Okay. Okay, the big piece was being able to justify or being able to conclude that, these 2 are equal, that's fine, but this angle and this angle are also going to be equal. So that makes all three the same, and the only way that happens is if it's an equilateral triangle. Okay. So now we consider this. Let's look. So they tell us these two are equal to each other. Okay, so shortly, if that's 3 inches, that's 3 inches. All right, so then if these two, this AC and this AB are equal, then their base angles are equal. So if that's 2x, that's also going to be 2x. But notice, that makes all three of them 2x. Okay, so all three are equal. The only way all three are equal is if that is equilateral. Okay, or equiangular. Either way, you know, they're one and the same. They're synonymous. Okay, so to figure out x, well, in an equilateral triangle, every angle is 60. So x is just going to be 30. And to figure out y, well, 4y minus 5 is this, but all three sides are going to be equal. So y is just going to be 2. Okay, so this is just because originally, you know, you subtly picked up that's an isosceles triangle, then we kind of concluded that, well, wait a minute. There's other things at play here that tell me this is really an equilateral triangle. It's an equilateral triangle trying to hide as an isosceles triangle. So that's kind of what my big point here is. Okay. Last piece. So now let's look. Okay, so they tell me that this is 80, and this is 6x plus 8. Okay, this is an isosceles. So this is also going to be 6x plus 8. But they don't tell us, you know, this is not one of those that's hiding, and you know, says it's isosceles, but it's really an equilateral. This is still an isosceles. But what I can do is use the fact that, you know, my angles have to add up to 180. Well, if I know this top one is 80 degrees, I can subtract it. Then I know that each one of these are going to be the same. So if I divide that by 2, because there's 2 equal ones, I get 50. So each one of those is going to be 50. So then I can solve. So x is going to equal 7. So then isosceles, y is pretty straightforward. So I get 2y equals 4. So y should equal 2. Okay, and that's just, you know, they're isosceles, they're equal to each other. So set them equal and solve. That's nothing too bad. Okay. So now in your assignment folder, you want to do the 3.1 through 3.5 assignment, and then the homework quiz and quizzes. Okay, there's only one more section after this, and then you will be done with Unit 3.